Welcome to my presentation. In this presentation we shall see some simple definitions related to matrices. So let us try to understand what a square matrix is. Let me write this here. Square matrix. Square matrix. A square matrix is a matrix where the number of rows is equal to the number of columns. So let's take a simple example here. If I have an example like this, A1, B1, A2, B2. The number of rows is equal to the number of columns. We have 2 rows and 2 columns. So therefore it is a square matrix. The number of rows is equal to the number of columns, so therefore it is a square matrix. Let's look at another example, another definition. Null matrix, or it's also sometimes called as zero matrix. So what is a null matrix or a zero matrix? When the elements inside the matrix are all zeros. For example, 0, 0, 0, 0. This is a null matrix. The elements in the matrix are zeros. The value is equal to zeros. Therefore, it is called a zero matrix. When we add 2 matrices, if the result is going to come out as 0, therefore we can then say the result of sum of 2 matrices or difference of 2 matrices is a null matrix or a zero matrix, and that's the way we can represent that. Let's look at a third definition. We want to know what a unit matrix is. What is a unit matrix? A unit matrix is a matrix if the major diagonal of the matrix are unity or ones and the remaining elements are 0, those types of matrices are called unit matrix. Example, if I have 1, 0, 0, 1, this is what is called the major diagonal. And the rest of the elements, the major diagonals are 1s and the rest of the elements are 0s. Another example, if I have a matrix of this size, 1, 0, 0, 0, 1, 0, 0, 0, 1. Let's say we have 3 rows and 3 columns. As long as the major diagonal elements are 1 and then the rest of the elements are all zeros, these types of matrices are called unit matrix. Unit matrix. Okay. Then let us try to define what a transpose matrix is. Transpose matrix. A transpose matrix is a matrix such that if the rows are changed to columns of any matrix, it is defined as a transpose of a matrix. Okay, so let us take an example. Let's take a simple example. If A is a matrix and if I have, let's say, 1, 2, 3, 4 as elements of this matrix, then I can write the transpose of this matrix, the T on the top, like the exponent here, A, this is read as A transpose is equal to, let me write here, these are the rows, this is row 1, row 2, row 2, column 1 and column 2. We take the rows and then transform them into columns. 1, 2 is the first row, so I'm going to write it as a first column. Then in the second row I have 3, 4, so that comes out as 3, 4 like that. So therefore, when the rows are transformed into columns, we can represent those types of we can define those types of that type of a matrix as transpose of a matrix. Transpose of a matrix. Okay. Then let's define what a symmetric matrix is. Symmetric matrix. A symmetric matrix is if the elements Aij is exactly equal to Aji, then the matrix is symmetric. Then we call those types of matrix as symmetric matrix. Then there is another definition. If there is a symmetric matrix, then there should be a skew symmetric matrix. Skew symmetric matrix. In here, if the elements, if Aij is equal to the negative of Aji, then those types of matrices are called skew symmetric matrix. Okay, so these are some of the definitions of matrices. So in my next presentation, we should look at examples as to how to solve problems related to matrices.